Hello all. Now we will understand the instantaneous description of Turing machine. What do you mean by the instantaneous description of Turing machine? Actually, this topic is included in the representation of Turing machine. Initially, we represented the Turing machine by first of all we had seen the mathematical model of the Turing machine. In that we had seen the representation of Turing machine by the seven tuples. Seven tuples was like a finite set of state, that is q, then sigma, that is set of input symbols, then tau, that is the tape alphabet, final state, initial state, then the transition function. All these symbols were included in the all these tuples were included in the representation of Turing machine. Now we are going to see the instantaneous description of the Turing machine. Instantaneous description, that is ID of Turing machine. At a particular moment or at a particular situation, how the Turing machine will behave, okay, at that current situation, that we are going to study here. So instantaneous description of a Turing machine is a snapshot of Turing machine to describe the current situation of a Turing machine. It describes what? It describes the current situation of the Turing machine. Transition: let the initial ID of Turing machine is x1 to xi minus 1. Q, this is the state. This x1 to xi minus 1 is the tape symbol. Then q is the state. xi plus 1 up to xn, these are nothing but the symbol. So it indicates that currently if the read write header, this read write header is under the cell containing the tape symbol xi, under the tape symbol, under the cell which is containing the tape symbol what? Xi. So here you can see that the state, this is the state q, and finite control is under the state what? Q, and the tape symbol, cell containing the symbol, tape symbol is what? Tape symbol is what? Xi. This is the tape symbol xi. Okay, so let us assume the transition delta has been defined in this way: delta q comma xy p comma y, it goes to which state? Q goes to state p, and the current new tape symbol, replacement symbol is y, and we are moving towards which direction? Left. So this p is the next state, y is the symbol which is going to be overwrite, and L means what? Read or write header will move towards the left from the one tape symbol. Okay, for one tape symbol, that is the read or write head was there just under the xi. This was under the xi. Okay, so it is moving under it, so it will move towards the left of that. Whatever the element is there, it whatever the symbol is there, it will move towards the left of that. Okay, so how we will write it? That means it will come under what? Xi minus 1. So it will come under xi minus 1. So before xi minus 1 we will, so I should write a new state p. New state p should be written where? Before xi minus 1. As it is coming under xi minus 1, it is moving towards the left, because here there was xi. Okay, here there was xi, and this xi is overwritten by the symbol y. Okay, so before xi what was there? Xi minus 1. So new state we will write it here. So I should write a new state p before xi minus 1, and this particular symbol xi will be replaced by what? Xi is replaced by what? Y, as the read write header, because we had written here y. Okay, this xi is replaced by y. As the read write header has shifted left, so I am writing a new symbol, whichever the new symbol is p, before what? Xi minus 1, because it is shifted, the symbol is shifted to the left, therefore we have to write this xi is here, so we will write the new symbol before xi minus 1, that is as it is shifted towards the left. Okay, so we will write it before this, that is p. Now similarly, so this is the left substring and this is the right substring, and this is the state q. So now, so x1 to x1 x2 up to xi minus 1, from here I had taken this. So just once again focus on this. This is what? Left substring. Then this is what? Current state of M. Then this is the current input symbol scanned by the read write head. So our read write head is currently here. Current input symbol scanned by read write head, and this is our write substring. So when delta of q comma xi, then it changed to which state? P. Then new replacement symbol was y, and it moved towards the left. So how we will represent it? Let's see this. Within this we have to write it. Okay, so how we will here we have to write the replacement symbol, whichever it is. So x1 x2 up to xi minus 1. So this was our left substring. Xi minus 2, left substring. Then here there was xi minus 1. Here you can see xi minus 1, and then xi minus 1, then the another state, and then xi plus 1 up to xn. So here this is the current state is P, which is changed from the Q. Current state, which is P, current state is P, which is changed from Q. And the read write header, this is the read write header, head pointing at xi minus 1 by one left shift. Okay, by one left shift. Previously it was pointing or reading the symbol xi. Okay, it was reading symbol xi. Now it is moved to one position left, that is xi minus 1. After before this, what would be then? Xi minus 2. Okay, like this. So now, and the symbol is changed to what state? Y. So symbol, this is the, this you can say symbol, which symbol? Xi. Xi is changed to what on the tape? It is changed to y on the tape. Okay, so like this is the right substring. Okay, so this is how we represent the instantaneous description of a Turing machine. So instantaneous description of a Turing machine is a snapshot of Turing machine to describe the current situation of the Turing machine. Means at the current, when the current input symbol is xi, current input symbol is xi, how what is the current situation, current inner situation in the while doing the transitions that we are going, that we saw here by representing it in the form of the instantaneous description. Thank you very much. Now we will understand about the language acceptability by the Turing machine. So now we will understand the language acceptability by the Turing machine. So Turing machine consists of the 7 tuples, that is q, sigma, tau, delta, q0, blank, and the final state. The language accepted by the Turing machine M, denoted by what? L of M. So L of M is accepted by the Turing machine in certain condition, is derived as the set of those words in the sigma star that causes the machine to enter into the final state when placed, okay, justified at the left end, okay, on the left, on the tape, input tape, we are justifying it on the starting, whatever the string is there, it is starting from the leftmost symbol on the tape of M, and with a M in a state q0, so it is initially at state what? Q0, and the tape head of the M is at the leftmost symbol. So tape head is at the leftmost symbol of the string. So W, such that W is in sigma star and q0. So a string is containing a sigma star, means that is the input symbols like A, B, like this input symbol it is containing, and it is currently at a state what? Initial state q0, or W's it is within the state q for P belongs to final state, and this P will belongs to final state. This is the left substring and this is the right substring, where alpha 1 alpha 2 belongs to tau star. So it belongs to tau star. Tau star means it includes the blank also, okay. So if the string is accepted, if the string has reached to the final state, then it is accepted by the Turing machine, and the such a type of Turing machine is said to be accepted, and it means the Turing machine halts after some time. So given a Turing machine M accepting the language what? L, given the Turing machine M accepting the language L, M halts, means machine halts, means Turing machine does not make any next move. However, if the machine is not halting, means if it is if it is not accepted, means the Turing machine will never halt, okay. If the input is accepted, then only the Turing machine will halt, and if the machine is not accepting the word or the given input, the Turing machine never halts. So this is all about the language acceptability by the Turing machine. Now we will see how to design a Turing machine. Let's see the design of Turing machine. Next topic. Design of Turing machine. We can represent the transitions of Turing machine pictorially. A transition diagram consists of a set of nodes. You know that nodes are there corresponding to the states of Turing machine. An edge from the state P to state Q is labeled by one or more items from the in the form like that we will represent. Then the transition is described as, for example, the transition is delta P comma X from current input symbol, current state, current input symbol. If it is going to new state, new input symbol, and the some direction, okay. So in transition diagram, and in this transition D is represented what? D is represented the direction, and it can be what? Left or right direction. You can represent in both direction, that is either in the left direction or the right direction. For example, consider the transition diagram of the Turing machine. So this is the start state. If it is in some state like Q0, and it has some transition like AAR and the other transition like blanks, if it is there, because on the initial state we had said that initial state contains a sigma star and the q0, so it can be a blank also, no issue in that. Then b comma a, move towards the right. When we move towards the right, we are going to the another state, that is q1. Then b neutral, there is no other moves after this. q2, then that is we are going to halt. So how we will represent this in the transition form? Delta q1 comma b we are going to q2. New state is, new replacement symbol is b, new state is q2 and no moves. Then delta q0 comma a, we can represent it as it is on the same state, that is q0. A new replacement symbol is a and we had moved towards which direction? Right direction. Then delta q0 comma b, we had gone to the same state, we are on the same state. New replacement symbol is b, right? We override by b and we had moved towards which direction? Right direction. Then delta q0 b, on the b when the tape head read write header is on the b, we write it by the y, write it by a, that is we had modified to a. We are going to state q1, so q1 modified symbol is a, converted into a, and we are moving towards the right direction. So now finally how to represent in the transition table, let's see. So there are two states, that is q0 and q1, and the tape symbols are a, b and capital B. Okay, these are the tape symbols. So initially q0 comma a comma move right, because q0 on a where it is going? q0 ar, that's why we had written here like this. We will write everything. q0 on b where it had gone? q1 a r. q0 on capital B, q2 blank neutral. Then q1 on blank, it has gone to q2 q0 on blank, it had gone to q0 blank and we had moved towards right. Here q0 blank neutral. Okay, this is what our design of the Turing machine. Now next we will see how to compute with the Turing machine. So hope so you are clear with that, how we are going to represent the transition IDs, then the transitions diagram and the transition table. This is all about the design of the basic construction of the Turing machine. Now after this we will see many more problems. Within that you will get a very clear idea, but this is the basic which need to be applied to each problem. So hope so you understood the three concepts, that is instantaneous description of Turing machine, then language acceptability of Turing machine, and what are the basic design requirement for the basic design of the Turing machine. So instantaneous description of Turing machine, what we had seen, this is the left substring and the right substring. You can assume this left substring as alpha, okay, and the right substring also as a alpha, and the state q. Okay, so here the q is a current state of the machine M, and this small q belongs to what? Capital Q, that is the set of states, and the alpha 1 and alpha 2 are the string in a what? Tau star. In tau star it includes what? Blank also. Then alpha 1 alpha 2 represents the content of the tape up to the rightmost non-blank symbol or the symbol to the left of the head, whichever is the rightmost. The important point to note is that blank may occur in the alpha 1 or alpha 2. It may occur, may or may not occur in alpha 1 and alpha 2. Okay, so let x1 to x1 x2 xi minus 1 q xi up to xn be what? ID, means the instantaneous description, that is the current state of the Turing machine, which is the current state of the Turing machine is q. The current read write header is at the input symbol what? xi, where the input string on the tape is x1 to x1 to xn. Assume that there is a move, and this is how the move is represented, and this is all about. Okay, left substring understand, and the right substring remember, where is the current state of the machine and the current input symbol being scanned, and by what state it is changed, and what symbol it is changed, and how it is described. Okay, so this is how the instantaneous description of the Turing machine. Now in the next series, next we will learn about how to represent, what are the techniques of the Turing machine construction. So there are 4 techniques basically that we will understand in the next lecture, next part. Thank you very much.